In this example, looks like we have ourselves a literal equation here. It contains both x's and y's as well as constants, and we would like to solve for y. So we'd like to get that y variable isolated on one side of the equation and all the other terms on the other. So one thing here that we see we also have are fractions. So we have this 1/12 that we're distributing through here, and then this 1/2 y. So there are two approaches that we could take. One, we could just work the entire equation and include the fractions. Or the other one is that we could do a multiplication at the beginning here and get rid of the fractions. So let's go ahead and do the latter, and we'll multiply both sides by the common denominator of the fraction in order to get rid of all the fractions that I have. Okay, so I have a 1/12 and a 1/2. So the denominators are 12 and 2, which the common denominator then of course is 12. So I would like to multiply both sides of this equation by 12. So when I do that, I'll multiply the 12 and the 1/12 here, and so they'll cancel each other out, and I'll just have the 9y minus 8x equals. On the right side, this 12 will multiply here and also here. So it looks like what I'll have then is a negative 24 to distribute through the 2 plus xy. And then 1/2 of 12 will be 6. So I'll have 6y right there. All right, so let's go ahead and do this distribution here. So 9y minus 8x equals, looks like negative 48 minus 24xy plus 6y. And again, we're solving for y, so let's go ahead and move it up a little bit. So let's get all these terms that include a y on the left side of the equation and all the terms that do not include a y on the right side of the equation. And so we'll go ahead and do that in one foul swoop. So we'll add 8x to both sides, and we will add 24xy to both sides, and we'll subtract 6y from both sides. So we'll just kind of shuffle all these terms where they need to go. So we notice on the left the 8x's cancel, and on the right the 24xy and the 6y cancels. And so let's not forget the x over here, so it's an 8x. And so what we have here is it looks like 24xy, that guy right there, and then plus 3y, and that will equal, it looks like, negative 48 plus 8x. Let's go ahead and put that 8x first because it's positive, and we'll tuck this negative kind of in the middle here as a subtraction sign. So here is where we are, and we're solving for this y, and you'll see that the y happens in a couple of places, but these terms are not like terms. This first term is an xy, and the second one is just a y. So we can't put them together. So the best we can do is go ahead and factor the y out. So we'll factor this y out. It'll look like basically the distributive property when I'm done, because factoring this greatest common factor behaves like backwards distributive property. So we're not doing the greatest common factor, we're just doing the y itself because we need to isolate that y. So we'll have 24x plus 3, and that will equal that 8x minus 48. So why this is so nice is on the left side I now have a product, so y times this expression. So in order to get that y all by itself, let's go ahead and do the opposite or the inverse operation of multiplying, and let's divide both sides by 24x plus 3. So I'll cancel it here and here, and the y will indeed be all by itself. So I'll have y equals 8x minus 48 all over 24x plus 3. So here is my equation. I solved for y, and that was from this initial literal equation that included fractions. So we went ahead and multiplied first by the common denominator, getting rid of all the fractions, and then I got all my terms that included a y on one side and everything else on the other. I factored the y out and I divided. And here's what we have for our final solution.